Welcome to the Human Odyssey, the podcast about human-centered design. The way humans learn, behave, and perform is a science, and having a better understanding of this can help improve your business, your work, and your life. This program is presented by Sophic Synergistics, the experts in human-centered design. So, let's get started on today's Human Odyssey.
Hello and welcome to the Human Odyssey podcast. I have an awesome guest today, Mr. Jacob Croft. We here at Sophic Synergistics will help you with human-centered design. This is an Applied Health Performance podcast. Again, Dr. Reggie O'Hara, Director of Applied Health and Performance here at Sophic Synergistics. And as I noted, I'm here today with our guest, Mr. Jacob Croft, who is the Director of Licensing and Commercialization, Research Innovation at the University of Texas, El Paso, UTEP. It's in El Paso, if you don't know. Today, I want to quickly read Jacob Croft's, Mr. Croft's bio. He's got an interesting background. He's currently the Director of Licensing and Commercialization at University of Texas, El Paso, where he helps move ideas and discoveries from university into the marketplace. In his role, Jacob works closely with researchers, entrepreneurs, and industry partners to turn innovations into patents, licenses, and new startup opportunities. Before joining UTEP in 2024, Jacob served in several roles around biological research and human disease models. Jacob has guided faculty and student innovators across various fields, including biotechnology, advanced materials, and energy technologies. He's passionate about connecting academic research with real-world impact and building collaborations that drive both economic growth and social benefit. Jacob's educational background, he earned a bachelor's degree in biological sciences from Arizona State University, a master's of science in biology from New Mexico State University. He's published over 10 academic papers in the field of human health and biological markers through various peer-reviewed journals. Jacob, welcome to the Human Odyssey podcast, my friend.
Thank you, Dr. O'Hara. I appreciate the opportunity again to sit down with you, and thank you for the introduction. I'm just happy to be here for this opportunity today.
Well, I'm glad you're here. Jacob and I go back quite a ways. The last 2.5 years of my 24-year career in the Department of Defense as a researcher, I had the pleasure of working with Jacob in William Beaumont Army Medical Center, Fort Bliss, Texas, the Department of Clinical Investigations. And we did some really good work there together. He was a contractor. And then he moved on to much bigger and better things. There's a funny story behind that. I don't know if it's funny, but Jacob probably thinks it's still funny. It makes me laugh. We'll tell the audience what it was as we get to the question that will lead into that story. But I think today is going to be a fun podcast. We're really looking at, licensing and patenting, how small businesses, also federal institutions can collaborate with academic institutions, because partnerships and collaborative efforts usually help enhance grants and funding streams for both all interested parties and collaborating parties. So let's start with a little bit. I always just like writing a paper, Jacob, background, right? Introduction, background. So from what we're going to talk a little about your personal journey and your leadership. So from the uniform now to the university, what do you think was the most unexpected skill or lesson from your military service that you find yourself using in your current tech transfer leadership role today?
Thank you, Dr. O'Hara. I took a very interesting road to get to where I'm at today. I started off my professional career with the United States Air Force, where I was an aerospace medical technician with a special identifier to be one of the few paramedics that they had. With that being said, I think that comes back to my leadership that I learned while I was active duty wearing the uniform, and that was I worked very well with small teams. I worked with fire department teams to get through emergency situations. where I had to rely on the people that may not have had the same medical training I did. Is I was the lead for medical calls when we are on scene. This has translated to my team because I want them to be as good as me. I want to enhance their skills where I'm not just the one leading the office, but I know that they're capable of performing in the event I was not able to be there to keep, in this case, the building running and everything alive. But in the case of the military, it was to make sure our patients stayed alive until we got to some advanced tier. So I think just by enhancing my team's performance and guiding them to get them to the next level is the biggest takeaway from when I was active.
And Jacob, how long, I forget, I know you've told me this before, how long were you active duty?
I was active duty for 8 years and 2 months. I got to go through Little Rock Air Force Base, RAF Lake and Heath, and then finally ended up in Holloman, which brought me out to the Southwest. I met my wife, and now, of course, I'm here in El Paso.
You're out in the farthest west you can go in Texas, and in the desert, literally in the desert, right?
Yes, absolutely.
I know I enjoyed my time in El Paso. It was about the last 2.5 years, but I remember, Jacob, when I was exiting, retiring, and I needed someone to help me with my little couch in my office. Do you remember that?
Yes.
It was a Saturday morning, and Jacob and he met me out there with his truck, and we had to load up my little office couch, which I put in the office once I first had arrived there. So we had some great experience together, especially writing papers. But, I want to jump now to some mentors and milestones in your career. Was there a person or a pivotal moment that set you on the path you're on now to licensing and commercialization at UTEP? And you can tell the story, Jacob, because it is a hilarious. At the time, I didn't think it was quite hilarious, but it totally caught you off guard, which I didn't mean to do. Just the thought came to me at the acute moment, and I said, I need to say something. So I'll let you take it away and tell the story.
Alrighty. Well, there's kind of a couple questions in there. Pivotal into getting me into this career, I have to thank Dr. O'Hare for that opportunity, and I'll get into that story. As a scientist, though, prior to getting into tech transfer, I had some good mentors that taught me just to surround yourself with interesting people doing interesting things. And that was from the late Dr. Matthew Gomper out of New Mexico State University, who unfortunately passed away a couple of years ago. He kind of stemmed me into getting into science and doing research, which led me to meet Reggie. And Dr. O'Hare here, I was working as a contractor, grants manager, doing some biological research with him on human performance, and my contract came up. It was an interesting time in my life. I was a month away from getting married, and then I found out my job was going away. We had a meeting at UTEP, and I was like, man, I'd really like to get into UTEP. Hopefully we can make some connections. I can find a career to go into from there. And lo and behold, we have a meeting with the VP of research here, and Dr. O'Hare just walks up to him and says, you need to hire this guy. He will do whatever you need, and he will do it to a level that you were not ready to see. The VP of research took it very personally, asked for me to send him my CV and my background with biological research. I've applied for patents. They did not get filed due to a technology readiness, which is oftentimes not understood in the lab. It wasn't filed, but I was familiar with going through the patent process. They really needed to stand up and rejuvenate the office. We needed to make that research translation from someone who understands what happens if research doesn't get translated or doesn't go anywhere. So that is how I ended up in this. There was a passing comment of Dr. O'Hare, and then since then we've really changed the look of the office, creating bigger impacts and working with faculty. So not only did he help me professionally in the science realm with paper publications, showing me how to better structure my papers and helping me publish, he also helped set me up for this technology transfer career.
So that just sent a little chill down my spine, Jacob. Because sometimes after I taught at least 3 courses. 3 courses at UTEP. 2 of them were online. 1 was in person. The last one was a graduate course I taught online. But as I work with students, which you're, not their age, you're older now, but I still view you as a young guy because I'm, an old guy. You have these moments of mentorship, and if you have some individual student or young colleague that's, I'm convinced that can exceed standards, because that's really how I run my life, is try to exceed the standard. Don't try to meet the standard. You're one of those individuals they're out there. There's not a lot of them, but there are those moments where you do meet them, and that's sort of, I view as a mentoring moment of, this individual wants to move up to the next level. They put in the time, the effort, they exceed the standards, and you were always one of those individuals. So as I told you a long time ago, I just put the invitation out there for the VP, but based on your credentials and your work ethic, I knew there would be no doubt that you'd be in the position you're in today, which I'm glad. Tell us a little bit about your current role, how you became involved in the technology transfer sector, and how that worked at UTEP.
Yeah, so how I became eligible for this job goes back to when I was working at a different university. I was a bench scientist doing work in human biologics, understanding that we need better tests to test for disease at earlier stages. I was working on a very specialized disease called cerebral cavernous malformations, and then we moved on to liver cancers. And we found that if you got biomarkers to detect at earlier levels, then you were more likely to have a better outcome for the patient. We applied for patents unsuccessfully. We were told our technology readiness wasn't to the par that they wanted to see for patents at the time. At the time, I was like, man, this really is unfortunate, but moving to the seat I'm in now, it makes a lot more sense. And I think that's something that's just not taught. So now kind of moving into my role is to make the inventions and discoveries of a university actually turn into a product that's going out to improve society in one shape or form. Now, I'm not limited to just biologics or human performance that I see here. I'm looking at devices, I'm looking at new machinery, I'm looking at new manufacturing techniques. All of these could progress society from where we're at today to where we wanted to be in the future. I don't know about you, but when I was a kid, I always wanted a jetpack. I thought it was just something cool. I could wear the jetpack and go to school. Well, it's thoughts like that are being discovered at the university that I go and meet industry partners, small startups, medium-sized companies, or large-sized companies to make the product developed through research at the university and protected through IP coverage in either patents, copyrights, trademarks, or trade secrets to be sent out to the public.
So some of the technologies that you're seeing now, Jacob, is there a lot of, in not just UTEP, but other universities, because I know there's some cross-sector work with the University of Texas, because there's other branches of the UT system. Are there a lot of those department heads and researchers within those departments that are collaborating? Do you see a lot of collaboration partnership going on between the academic institution and let's say the small business or biotech startup? Is that a small percentage, or would you say it's greater than what I think? Because I look at it as it's not a real big percentage. The universities aren't necessarily reaching out to these startups or small businesses, but it almost will be impossible to figure out who's doing what. So how does that work? Is there a lot of collaboration going on with these small startups and companies?
Yes, I would start to say it's growing. There's unique funding opportunities that align for small businesses or businesses that have been established to work with university partners to develop technology. And this is seen through the SBIRs and STTR grants that are from, the NSF, NIH, DOD, all the departments of the DOD. There's multiple opportunities, but in that grant specifically, you have to work with a small business or established business and inventors at a university to better develop inventions that have a tangible outcome for change in society. Recently, there's been another grant posting. It's called the NSF TTP grant. It's a series of 3 different types of grants that are looking for industry partners to be involved with the inventors at the university. And the whole goal here is make something that is ready to go from the university and able to be handled by the company to sell to change the lives of the people around them.
Yeah, when you say small SBIR, it's Small Business Innovation Research, and STTR is Science Technology Transfer Research. So that's the difference of people are driving down the road, coming to El Paso right now, right? They're driving down the road and they're saying, what the heck is SBIR, STTR? So usually with the Small Business Innovation Research, the SBIR, can you differentiate what are the differences between the SBIR and STTR? Are there's some differences in the amount of funding that's available through each one is also different.
Yes. I'll start with SBIRs first. I will say I have more familiarity with them. There's multiple phases available. Depending on the grant funding that has a different amount associated. There's phase 1 and phase 2 funding that we know of, and then some will offer a phase 3 funding for advancement of this. Typically, this is where a company is partnered with the school, and the school is going to be the primary funding agency. If we go STTR, the other side of this, the funding is available, but typically the funding goes through the small business and is subcontracted into the school that way. Both of them have different benefits based on what you're looking for, but they both are looking to have the same thing, and that's a change of the invention that is going to have outcome on the society around it. Society as a whole being America, because these are typically funded through our national granting agencies, but you want local and large-scale economic change.
So with the STTR, though, the Science Technology Transfer Research, do you have to be, you must be partnered with a nonprofit institution, right? Like it could be a DOD facility or a academic institution, but what a SBIR, SBIR, you don't really have to partner up. But what I always tell people is it's probably better to partner up no matter what, right? Like especially if you're writing a grant, because they want to see the team expertise level, past publications, preliminary data you might have to include in the pre-proposal. And then if you're invited back for a full proposal, to include that in. And I think, would you say that SBIRs usually have a larger pot of money than STTRs?
From what I have seen, I would say SBIRs do have it. They're the more common one to go after that we see from the university side.
Right.
In the industry side, you may see more STTRs, but they do. You really should partner with a researcher at the university for it. You want that technological expertise available for you to apply directly to your company.
Awesome. So Jacob, there's always this issue, and I recently went to a conference about a month ago. It was an SBIR, STTR conference hosted by the DOD, some parts of the DOD, not all the people were there, but, Navy was there, Coast Guard was there, Air Force was there. And it was interesting, but, I was talking to a lot of these small business companies and some of the CEOs that this was sort of their first time, delving into, well, how do you actually get a SBIR? How do you apply? How do you get an STTR? What are the rules? So that was basically what they went over. But the recurring concern or question from a lot of these small business CEOs was, well, how do I actually, partner up with somebody? How do I, if my company is not, it's a small business and we've got some innovative tech we're working with, I really need a partnership. So how have you seen that working at UTEP? Is there, are there a lot of small businesses reaching out, or like who identifies who would be a better match, or does this sort of happen naturally in the ecosystem?
So I think the first part of that is you got to identify you want help. We at the university don't know what industry is always wanting or looking for, especially in the small business realm. If you're looking to do a SBIR, STTR, anything in that realm, a good place to start is your tech transfer office. Our office incorporates an economic development component to it, and the person in that position is responsible for connecting expertise from the university to the business themselves. You present us a problem, we'll find you the correct solution for an inventor to meet with you to discuss the efforts that we could have going forward. It might not look the same at all schools. It might not look the same at all UT schools. We each run it a little bit different, but typically if you start a technology transfer office, we're always looking for business leads that may be interested in technology already developed, or we can put you in touch with the right person to get you coordinated to write this SBIR, STTR.
Awesome. Let's still dive a little bit into what do you think makes the intersection of the university, for example, UTEP, and the federal government unique in the innovation ecosystem? Like, is there a lot of partnering going on with DoD entities? So, for example, if I'm at UTEP and I'm in the Department of Health Sciences and Human Performance or kinesiology, and I have what I think is a brilliant idea and I've got good preliminary data, then is it better for that individual sometimes if it can be applied, if it has military applicability, to partner with someone in the DoD? Or does it seem, in your case at UTEP, that a lot of these professors, researchers there don't really know who to reach out to in the DoD, or if they do know who to reach out to, they'll tell you, not all of them, that it's nearly impossible to find someone that they can collaborate with the technology they developed at UTEP?
Well, that's an interesting question. I think it kind of takes me back to my old hat of looking at grant management. Each of these DoD sources has their own pot of money to fund research through publicly available grants. However, each university could also have direct contacts to national labs, federal entities, and this can come in the form of sponsored research, where if we already have the established relationship with the military branch, or if we have it with a national lab, we can reach out to those contacts and ask them what are their problems that they're having, and can we help them provide a solution. This is usually what results in sponsored research agreements. This can develop IP, but it can also be a quick fix. When I say IP, I mean all intellectual properties. Sorry,
Yeah.
The old military side of me loves to stick to acronyms.
That's natural. That's natural. So I want to jump now into sort of behind the scenes of innovation and technology development. Can you share a lesser known success story, maybe something surprising or even humorous that came out of a university federal partnership? Is there any like specific stories you might have since you've been there? I know you haven't been there a real long time, but you've been over there over a year. So have you run it? Do you have any stories like that where it was, something surprising or even humorous that came out of that collaborative effort?
Yeah, maybe not so much in the case of humorous, but just kind of learning more about my local ecosystem here is we recently signed a deal with a company for some technology that they had written SBIRs with at the university to develop it further along the technology readiness levels. As that increased, the company decided they wanted to take a licensing opportunity to get into a realm of manufacturing I didn't even know existed in the El Paso region.
Yeah.
So we're starting to set up work in the space realm here with this company. I kind of have to be a little vague about it because the
Right.
contracts and
Right.
information in place. But just knowing that industry existed in El Paso was something that wasn't advertised in the past. It wasn't something I, you know, I, if I told you the realm it was working in, you'd be like, that's happening in El Paso right now. And it's really cool. I think it's going to lead to workforce development in our area and have some economical change in the region, which is really unique as we're on the U.S. Mexican border. We kind of get forgotten about sometimes about some of the technology getting developed here, but it's like, no, this could be the next thing that's going to really change that industry.
Yeah, I think El Paso, when I was there, it wasn't like an Austin, a biotech hub. But as I talked to some industry leaders around there, especially when I was teaching at UTEP, I was starting to learn that El Paso's trying to grow that, sort of becoming I wouldn't say a prime biotech hub, but a community where biotech could generate startup companies, and which would increase employment rates, et cetera. So I think you're right. That's sort of, it's a slow progression, but as when I was leaving about, a year ago, it was starting to ramp up a bit.
Yeah, and we're really seeing it start to catch with this. Like we're moving forward in the right direction. We have one of the most advanced manufacturing facilities for a university at the campus. So it leads to a lot of really cool aerospace and mechanical engineering designs, which, is not my wheelhouse, but getting to work with them and making these partnerships with the local companies. We have a large Army facility here, and we have an Air Force facility just down the road. We're able to make these connections and see the technology continue to be developed that's starting from our inventors here.
So how do you decide which university inventions, let's say I'm a professor and I think I came up with a great tech, and I think it's worth protecting or licensing. How do you determine which are better left on the shelf, or which ones, well, yeah, this is an innovative idea. We're going to conduct a patent search. We don't see anything like this. How do you determine what is worth protecting or licensing?
Yeah, I have this beautiful saying. You can't see it. It's over to my left. It's technology without an application is not a good technology. So how do we find that, right?
Yeah.
If you came up with the way to drive a car specifically for the planet Neptune, it doesn't have any application here. So we have to come up with rules to figure it out. First, I conducted technology readiness level assessment. That's a scale that's going to be from 1 to 9. 9 being it's ready to go out of the box tomorrow. The company just needs a license, make it, and send it to the person. It's completely tested in its environment. And 1 means I drew something on a napkin, and it's a really good idea, I promise you. Typically, what one of the challenges seen through universities throughout America is that most of the technology readiness levels we're seeing are about 3 to 5. It's all set up for prototypes in a lab. It's tested. They get the results. A publication and a patent typically follow. So we need to be able to assess where we're at on that. I don't really want to invest a lot of money unless I know that it's going to be able to work the way it is. I want a prototype. Plus, then we're going to do a market research analysis. This is something that you typically need a very good business background for. Thankfully, that was one of the things I recognized very early and brought someone with a business background into my office. We need to figure out what's the market. Is the market something that's slow and stagnant? Is it something slow to adapt new technologies, even if they're revolutionary? Is there a lot of federal guidelines that are in place? Is it slow and stagnant, but it has a high profit return? If it that's the case, we're more apt to want to work with this technology. Is it something that's the blue chip? This is the leading edge of the market itself. They're quick to adapt. They're moving above the annual GDP of the country. They're always looking for new technologies. We love those technologies. And finally, there's the roller coaster. Sometimes the market's high, sometimes the market's low. It's like you're playing the stock market, figuring out if they'll adapt to technology or not. Once that's done, we kind of get a snapshot of, well, is it ready? And what's the market going to look like for it? Then we move into a technology assessment. And this is what takes quite a bit of time. We have to review all patents, all public information. So anything in the public domain, think papers, dissertation defense, thesis defenses that are all made public, any poster presentations, anything in that nature where you're telling someone your idea. If there's something that exists in the public domain that would block a patent or block some of your claims, it's not going to be fruitful to move forward. Now, say, Dr. O'Hare, you came up with a new invention and you talked about it at a conference yesterday, right? You're like, oh, maybe I need to go talk to the tech transfer folks I work with. What you did do by making that public disclosure is you lose all international patent rights by making a public disclosure without filing for anything first. The U.S. is very unique in this, that we have up to 1 year from that public disclosure to file for anything in patent rights. A little bit different in copyrights. Definitely don't go tell your trade secrets to anyone. And trademarks are a little different because they're looking at a shape, image, or slogan.
Right. So do you think it's a good idea, Jake? Let's say I wake up one morning, put my eye drops in at 5 a.m, and I've been thinking about this great idea for this technology, or maybe adding a component to a technology. Is it better at that time if I get it all on paper and to do a provisional patent? Like take that idea straight to a provisional patent, and are there any restrictions with filing a provisional patent? Do you think it's worthwhile to do that?
It really depends on how much, if you're doing it as a single entity yourself, how much you believe in the idea, or if you're filing it at an institution, what's the risk with it? If you file a provisional patent, it gives you up to 1 year to continue to advance the technology before filing for a non-provisional, where you could put all the new claims in. I typically have researchers that will come to me at different stages of this, from I woke up with this great idea to I've done some testing and here it is, and ask me, do you think it's ready for a patent yet? I can let them know when to disclose, but I do not provide legal advice because I'm not a practicing attorney. I don't have the legal background to give them that advice, but I can tell them what we're looking at when we're looking at these disclosures. If the technology readiness level is lower, we're going to be less likely to want to file on it. If the market looks really bad, that's another strike against it. If there's other patents that exist or papers that exist in that realm that could block that patent, we're going to want to shift their direction a little bit. One practice I like to do is everything I find about any of these disclosures, if it's positive or negative, I give it back to the inventor. I don't want you to waste a bunch of time in your lab and research dollars to pursue something that may not get protections because something already exists. I think transparency is key because, hey, this already exists. Maybe I need to shift my research a different way. All that money they would have sunk into that can be into their future ventures.
And, as you get deeper into the weeds with it, you always want to see a patent attorney.
Yes.
Those are always good people to help advise you through the process if you're going to either file for provisional, because provisional there's some pretty strict timelines before you lose it. It's not very expensive to file it. But once you do file it, it's sort of, well, you're on a timeline now, and then you get down the road and figure out this isn't going to work. So you've really it's really has to be a long thought out process.
Yes, I agree. Especially typically the cheaper way to file a provisional is a 1-page provisional, but you could do full ones that are the whole entire patent claim if you have that information. But once you turn it into a provisional, the clock starts for 1 year. You have to convert.
Yeah.
So if you don't think you're going to make it there, I highly encourage you to keep doing the research in the lab, get it a little bit ready, get some proof of concepts behind you that it does work the way you think it does.
Jay, I have another question. You sort of answered this. How do you best align technology transfer when it involves, a university and a small company like the one I'm with, who routinely write these federal research development science technology grants? Say I'm writing a grant and go, wow, this has some good potential. It's a novel idea. How do you figure that out? Does someone like me just call you, or should I already have some point of contact at the university, chair of the department or a professor? Or if I don't, how do I figure that part out?
Let me ask just one clarifying question in this. Are you looking to co-develop this technology further with someone at the university? Or are you looking to file yourself?
Let's say it's gonna be a co-development project. We're gonna collaborate on the grant, and then if we get invited for a full proposal after we do the we're gonna both write different sections of it together, and then afterwards we're gonna designate someone to submit it through like eBRAP, for example, to meet all of the deadlines that are required, and then let's just say all of a sudden the money's awarded, but in that full proposal, we have to detail the budget of, well, what does the university get and what do I get, right? Is there a set amount % that the university does get? Like, they have to do 33% of that work?
No, that's going to be something that is determined by the two inventive parties together. I will say inventorship is federal law. It's not something my office gets to determine, hey, it was you that did 10% because I don't want to pay that much for your side, or my inventors did 90, so I'll pay more here. No, that's something that comes from the inventorship team, the two parties working together. I don't determine it. I only report what is reported to me, because I can't tell you how much effort was done by you versus the inventor at the university. That's something that there needs to be a meeting of the minds between the inventors to say, hey, I did 25%, maybe you did 75%. And that kind of determines what entity will file. But inventorship is federal law, so we do have to follow that. We can't make any determinations that would change interest from the university standpoint or the company standpoint. It's all what is reported back to us.
So let's take it another step. Let's say that's not technology. It's just a study we want to do, right? And we have not necessarily a technological innovation, but let's just say maybe something that can predict health disease down the line, right? Some formularies that we have, and we decide to write the grant. How is that's going to be different from technology transfer? We're going to both write the grant, but we're going to also have to have, let's just say, our population is going to be a certain subsection of the military population or the civilian population. Is it then, how does that work? That's going to be different than the invention working together on an invention, correct?
That is. So that would be something that's going to be handled by a different office than the technology transfer. Every university should have a grants and contracting office that would help with the proposal development, deciding where that budgetary line is, how much F&A would cost, which is the financial aid reimbursement that the university gets for it, and kind of help dictate that guideline of where the work would. But typically the work and the plan of the work is all developed by the inventors, or in this case, the principal investigators together.
So let's jump to this now. Let's jump to my favorite part, because I did a lot of these when I was at the Air Force Research Laboratory. I became a pro, but only through somebody that was in charge of the Cooperative Research and Development Agreements, the acronym CRADA, CRADA. Let's just say I'm a small business biotech company. I'm registered, I have my NICS codes, et cetera, and I want to collaborate with a professor at University of Texas, El Paso. And my company typically says, well, we're only used to doing non-disclosure agreements, NDAs. How do you handle that situation if the company's like, well, we've never done a CRADA, and is it necessary, is a university required that you have a cooperative research development agreement, even if it's with a small business?
Yes, those are, again, they get handled by a different department than me. But
Yeah.
I'm very familiar because anything that has any intellectual property clause in it comes through my office. Um, what we see is there's not just CRADAs. CRADAs are typically the federal government handling of this, but we have MOUs, which are the mutual understanding agreements. And that's kind of saying, hey, we're going to do this work and you're going to do this work. Here's the dollar amount between it. There's sponsored research agreements that kind of outline this as well. Typically, all of them have some form of research plan, some deliverables that are seen through the contract, are who's going to do the work where. Typically, what's seen in the CRADA, just in a different non-military term for them.
Are there any specific technology in this initiatives right now? You don't have to dive into. I know there's some things you can't share. Some of the more popular or up and rising technology initiatives that are most critical right now in the federal landscape.
I think what we're seeing is a big push for rare earth metals. It was outlined in COVID that we have supply chain issues with rare earth metals. It also was discovered that some countries that may or may not align with us are the main developers of these elements. So we need to find a way to extract them in the U.S. and be able to use them, process them, and develop them further. This can also be seen through our CHIPS Act that was enacted a few years ago, wanting to make more semiconductors and computer parts available in the U.S. Well, with that, you need the rare earth extraction to have those rare earth elements to be able to make these semiconductors and computer components.
Anything else that you see that's up and coming in maybe the biological, if we talk about DARPA, Defense Advanced Research Programs Projects Agency, that's like a dark hole with DARPA, very good organization, high 80% failure rate, 20% success. They seem to like to take risks. I'm not sure if they like to take risks for people on the outside, but they sure do on the inside. Are there any folks at your university that are working with some kind of, I call them out of the ordinary tech through DARPA? Is DARPA typically, in your opinion, an easy organization to work with?
I've never directly worked with them. I will say that in this role. I have heard from some of our industry partners that are working to get those types of grants. Kind of a high risk, high reward type grant. I think a lot of their initiatives are key, but I won't see any results of any partner at the university working on it typically till the grant's over and the results are in. That's deciding if they want to file for a patent or any kind of intellectual property, or if they have to go into a trade secret or not.
Now, very good information. I think people on the outside in small companies, startup companies, because there's a lot more than people know of out there. And I discovered this when I went to a conference right outside Washington, D.C. in Virginia about a month and a half ago. That's when I realized, like, these small businesses, this is like a dark hole working with the DOD. And, they always say they want to make it simple, right? You and I both know, because I worked for the federal government. When you're on the inside, it's still not that easy. Like a lot of people think, well, if you're on the inside, it's much easier. It is easier. You have access to more military populations, right? Versus when you're outside, what we call outside the wire. But it's still sort of not an easy road to navigate for small companies, because I know there were a lot there that seem to have some up and coming tech They had good preliminary data from what they told me, and they were just trying to figure out the landscape. So it does take individuals a lot of time to understand what's required. And I would say, do your homework. Do you have anything to add to that? Am I missing anything?
Yeah, I think the key thing if you're a startup company around tech is do your market research. It's good to know that you've contacted your buddy down the street and he says it's a great idea, but what you really need to know is like, is there room in the market for this, or is there even a need? Because again, that technology without a place is not a good technology. We really want to see the technology that is filling a problem. How I look at it from the technologies that are presented to me, these are all just solutions. I have lab tested solutions. Now I have to go find the problem and make sure that that's the problem that needs to be addressed by society. Or is there that problem that exists outside the lab, or is it a lab environment only? So make sure you do your market research. Make sure that the people out there are really needing what you're wanting to advance, and make sure it has a place to grow from there.
So in other words, people need you heard me say this a lot when we worked together, Jake. I don't know if you remember, I'm sure you do, that you need to do a deep dive into the scientific literature and a deep dive into the United States Patent Trademark Office. And before, you really think your idea is great, and it could be great, but most of the time what I've found, not all the time, is that it already exists. And a lot of students or young researchers will think, well, this has never been done. Like, we were doing that a decade ago in the Air Force Research Lab. So again, deep dive homework, not like ground surface homework to figure this out.
Yes, I agree with that. And not only doing the deep dive in the scientific literature and the patent literature, because you got to look at patents not just in the U.S., because you could get blocked from a patent in Canada that stops your claims. So you need to look at the whole world, and then realize that maybe that technology didn't move someplace for a reason, and usually the reason's the marketplace. Like, is there the demand in the market that fits your technology? So starting a business is hard. Anyone that's told you different is probably not doing too great in the business. So
exactly.
It's always going to be a challenge, but like knowing your marketplace and knowing how your technology fits into that marketplace is only what's going to lead you to success in the long run.
So the market analysis, Jacob, is really critical too. So let's say you have a small business, right? And they're developing a technology, and they have the research side, deep dive into the literature, USPTO. They can do that part, but there's that other part that you're talking about, that deep dive market analysis. What should the small business do in that case, or the startup company? I mean, should they go out and, how do you identify who can really conduct this analysis with some reliability? Right. Do you have any suggestions for that?
Yeah, there's a lot of great technology and open source areas that you can start to look in to help you guide this process. But you got to keep that same curious mind that you had when developing the technology to get to that next level. You have to investigate the market. So go ask companies working in the region, hey, what are some problems you're seeing? Would something like this possibly be a solution? Or how do we overcome the problem? Or what have you done with this problem in the past? Again, don't disclose what you're doing because you don't want to make a public disclosure of your technology, but you really want to understand like what established companies in the area are having struggles with, and how can you overcome them. Now, if you're a small company looking to do this, you want to look probably to the medium-sized companies or the large-sized companies. I would probably say look at the medium-sized companies because the large-sized companies have their own R&D realm and they're already trying to overcome that. But the medium-sized companies might not have an R&D realm, or some of the smaller business that are around your startup might be experiencing the same problem. You can come up with a joint venture together to have a solution for this problem that's presented.
That's important what you said though, Jacob, and I know this, but when you mention it, I think that the market, so there's like a 3-pronged process here, right? It's like, okay, I scribble my idea down here. The next thing I go into the scientific literature, deep dive. Okay, check, right? Now I'm going to go to the USPTO worldwide, check. But a lot of companies, I'm going to posit, don't think about the deep dive into the market analysis or reaching out to the medium-sized company, correct? I don't think a lot of companies or startups think about the importance of that. It's sort of like if you've just been a researcher, you're just thinking, oh, I'll just do the systematic review, meta-analysis, check, USPTO, deep dive, check, and then, well, you're missing that deep dive market analysis, which it probably holds as much weight as the first two. Would you agree?
Yeah, I'd almost say it carries more weight. And the reason I say that is typically if you're coming from technology you invented, you're going to be an expert in your field in research in that field. But when it comes to business, you may have all the educational background that you need to complete the invention process, but you may be completely absent-minded about starting a company, and that's its own monster. But thankfully, there's a lot of really good programs. There's typical chamber of commerce in each city that has some form of small business office to help guide you through this, from simple things like forming your LLC to like classes on how to find venture funding to get you to that next realm. But before you even approach them, you need to understand, is there even a fit for you to go forward with this? Because that's where a lot of startups fail, is they don't look outside of the idea of what they're building. They just look at, I have a really good idea. This is my baby. No one tells me my baby's ugly. Everyone will buy it.
Correct. So I want to dive right now a little bit into the student involvement in innovation. How can students, from undergrad, senior level to the graduate level, or let's just say very early career researchers, plug into tech transfer work? And are there programs at UTEP that support those individuals?
Yeah, so there's unique opportunities along the way. If you're someone that's working in STEM already, you're involved in a lab, it's always good to ask your PI that you're working under, hey, what is IP? They should have a general idea of it, and they can always guide you to the tech transfer office. What we've done here is I've had several graduate fellows working for me out of the Mike Loya Center of Entrepreneurship on the campus. And what we did is we taught them entrepreneurship through tech transfer. The concept is everything I'm looking at to decide if the technology should move forward is basic steps that you should make when deciding if you want to launch a company. I'm just presenting you the solution, which is the technology. For the technologies I use all that are public available information. So I'm not violating any NDAs. I'm not violating anyone's provisional technology, but I'm taking you through the steps of, hey, let's start with a lean business model. Okay, here's your business model. You've identified the problems. What's the key industry players? The industry players are this, and this is the areas they're growing in. Now, how does your technology fit into this marketplace? And is it a good fit? What are any technological hurdles that you have to overcome? Do you have to do FDA compliance? Do you have to go through clinical trials if you're testing a new drug? Like, these are all things that add up that if you're starting a company, you might not be thinking of. And finally, I give them a very open-ended question of, would you have filed on this technology or would you have not? Would you start your business with this technology or would you not? And why? Because then it's not just yes or no, it's yes or no, and this is why. Here's the hangups, here's the challenges to making this actually be a commercial product. Here's what we have to overcome. Here's what we would probably want to do before we started a business.
You just brought up, by the way, STEM, for the people out there that don't know this acronym, is science, technology, engineering, math. So when you hear STEM, Um, it's a good point. So when I was in the Air Force Research Lab for many years, and I was there at a time when they went to a lot of science and technology initiatives. And that's when researchers were like, I need to get a patent. We had a patent wall of fame at AFRL in the command center. This was like a big deal. But a lot of the very smart people would come up with these innovative technologies and they would patent it. It would be patented for a specific niche population in the military, but then it would sit on a shelf because even though AFRL would license it, put it out for licensing from small businesses or companies, it didn't fit the niche on the outside in the industry, in the civilian world, right? Some of them did, but not a lot. But some actually did and were very return ratio was very high. But that's something to think about if you're a federal researcher, which I'm not anymore. Is that how are you going to commercialize the product? Because the bottom line was back then is that if it's got to be designed for the military, for military use, for a population in the military, but then how are you going to take that and commercialize it? Because if you're spending that much time on something, your royalties you didn't get any royalties for that, which is fine because that's why you're there. That's why you're employed to help the warfighter. But then if you can commercialize it, you get a certain percentage of those royalties. So it's just something that I think takes us back to what you mentioned earlier. People don't think about that, right? They're thinking, this is cool, it's going to work, and it might work for that population, but then how can it be used? And you mentioned this several times for the world, right? For just common everyday people. Which, that being said, a lot of technology, like your GPS systems, is just one. Super glue is another one, right? I think there's several more. Duct tape's another one. All were in the military for a long period of time, and then finally, it can be used by civilians now. So that does happen sometimes.
Yeah, and I mean, we see it still at the university level. But we get a bunch of technologies that we think have places to go, and sometimes they don't. And it again gets back to that market fit and technology readiness. In the lab, it's one thing. In tested alpha and beta studies, completely different. It may not perform the same way.
Correct. Jacob, is there can you speak a little bit about, you might not have the precise answer, about the economic ripple effect of UTEP's tech transfer work in the El Paso region? Have you seen any of that?
I think we're starting to.
Okay.
I still think this is a building process. Part of it was we needed to start commercializing more, and that's something I came here to do. It's not as simple as just, hey, this company is a good fit. It's a process. The last license deal I signed took 9 months of either letting them test the technology for a time period to finally signing the deal that they can now produce it. So I think as we have more time going on and more local economy needs being met, we'll start to see a ripple effect, and we'll see technology continue to advance in the El Paso region. But it's something that isn't going to happen overnight, but we're working to make it happen today.
Yeah, one thing I've learned, Jacob, is science doesn't happen overnight. Right?
No, it is months in the lab.
Yeah, months in the lab, and it's a very rigorous process. So again, for the innovators out there, do your homework before you start investing your entire life towards it. And then sometimes, even after you do your homework, there's still a risk, right? There's risk with anything. Then you just have to go on your intuition, your gut, not your brain. You don't want to overthink it, and just go see if it works. And sometimes you might hit a gold mine, sometimes you might not. But there's always lessons learned from not being successful, from failures. So lessons learned to help you get better. That's the way I view it.
Oh, absolutely. Everyone talks about the success stories, but there's plenty of other ones that are not successful. But
Correct.
well, it is, a financial burden as you're trying to start up these companies. It either tells you that that's the field we want to pursue, and typically we see startups come out of universities. We see it at like the Stanfords, MITs, the UT Austins. They have a large eco space for it, but in smaller schools and smaller areas that are less um, enforced by like a science park that's right off the campus, it becomes its own challenge in its own right. And it's working with like city partners and county partners and how we can overcome and align goals.
So again, partnerships and collaborations, and I'm going to stress this part, Jacob, you know where I'm going with this, right?
Yes.
With the right people, right? That
Yes.
actually have their investment into the project is the same and in alignment with yours. You don't just go out and say, I think I'll partner with this big company over here. They seem really good at first, but then down the line, things kind of go sideways. So just make sure you're very picky about who you work with.
And make sure you read your agreements.
Yes, read your agreements. Absolutely.
Have your attorney read the agreements too to make sure that's a sound idea.
Yes. So final question, Jacob, how do you see the future of technology transfer evolving in the next 5 to 10 years? I know it's a wide open question. You can't really predict maybe a decade, but let's say the next 3 to 5 years. What do you see? What do you see with that?
Yes, there's been a few papers that have been published lately, kind of about the changes in academic thinking across America, going from the academic university to the entrepreneurial university. And that's not saying the university is out here to make money. That's not the goal of what an entrepreneurial university is. The goal of it is to make the technology that is developed at a university and get it out to the public. I think we're starting to see some academic revolutions where it's like, hey, the research we've done for decades is great, but what effect are we having on our communities? Let's focus on how we can get it out to our communities from there. There's some really good papers about how this transition has started at some of the bigger schools, like Stanford and MIT are two of the schools referenced in the paper I'm referring to. But I think all of the schools are starting to get in line and get in track with it. It's, hey, let's be forward thinking about our community and how we can solve the problems in our community and go from there.
Jacob, any final words, closing words that you like to sort of summarize everything when it comes to technology transfer for people out there that are, startups or early career researchers? That could be in a, for-profit business. It could be in a not-for-profit federal entity. Any closing comments?
Yeah, I would just say for the early academics, really go meet with your technology transfer offices. Like this was something as a scientist working in a lab I didn't think about. I was just thinking about how to get my research project done, publish results. But where does your results go from there? Like, yes, you have the paper, but did you change society? And that's the end goal of science is identify the problems that society's facing and make those changes for the future. You can only improve our lives from that. So meet with your tech transfer folks, meet with patent attorneys if you're a small business, and look at how to protect your ideas and also how to get them out to the people.
Very good, Jacob. Summarized very well. So this has been this is going to wrap it up for this edition of the Human Odyssey podcast. Mr. Croft, Mr. Jacob Croft, where can people out there find you? Because there could be some people out there, driving down the road, they're working for a small company. You've got a bunch of Jeff Bezos out there in their garage right now developing some technology. And they're like, well, how do I move this to the next step? Where can they find you?
Yeah, I'm pretty much exclusively on LinkedIn. It's gonna be linkedin.com/JRCO2. Or you can find me on ResearchGate. We're gonna have a couple papers coming up about, that technology teaching entrepreneurship. Hopefully releasing soon. It's in peer review, but I'm happy to answer questions. You can also contact me at my email at jrcroft@utep.edu.
And let me just say this to the audience, because I know you, Jacob. No, nobody else knows you quite like I do. Is that you might be the technology transfer guy over at UTEP, but you still work feverishly in research and publishing papers. You don't just sit in the office. You're still pretty involved with doing some pretty groundbreaking research, and you continue to find out what's the newest thing going on, what's the best tech going on, because you're always in the literature. I know that.
Yeah.
So that's what makes you really good at what you do, because you don't just stagnate. You're always looking to, what can I do next? Even if it adds on to the work you already have, that's what makes you, in my opinion, perfect for the job you're in, because you've got that tech research development background that you are continually updating it through peer-reviewed papers. And you have the applicability where you're sitting in the office having to actually apply some of these new learnings and this new knowledge.
Yeah, that's something I always try to do and bring to my office is, hey, let's find the leading edge and let's keep building on it. And once we figure it out, we're not going to hold it. We're going to tell the world, like, hey, this worked for us. Maybe it might work for you. So I have a motto that's above my office desk, and it just says, always improve. I'm not going to ever say I'm an expert in anything. I try very hard, and I try to share as much knowledge as I gain along the way to anyone that wants to listen.
Well, Jake, we have to say this: UTEP's lucky to have you. I think they're very lucky to have someone like you in that job. So our podcast is available on sofixsynergistics.com/. We have also video versions that can be found on YouTube and Spotify, and audio versions as well. Keep an eye out on our social media. We can be found on YouTube, X, and Facebook. So this has been a great podcast, Jacob, and you've been a great guest. It's a pleasure to have you back. And also, it's nice to see you again, because the last time I saw you was when you and your wife were visiting my home in El Paso, and we were out in the backyard by the pool. It's been a while.
It has. It's great to see you, Dr. O'Hare, and it's great to be here. I appreciate the honor of bringing me onto the podcast and getting to talk to you.
Thank you so much.
Thanks.
The Human Odyssey is presented by Sofix Synergistics, the experts in human-centered design. Find out more at sofixsynergistics.com. Get smart. Get Sofix smart.